Okay, lesson 5 in trig, the ambiguous case. Sorry about that. If you're given the measure of two angles and one side, or an angle formed by two sides, SAS, or all three sides, SSS, then there's only one possible triangle solution. You're saying to yourself, Mrs. Finley, what does that mean? Okay, say we know this is our triangle, and we know two angles and one side. So we have angle, side, angle. We know those. Okay. Or if we know side, angle, side. So we know three altogether here. Or we know side, side, side. But we don't know any of the angles, but we know all three of the sides. So if we have this situation, any one of these three situations, there is only one possible solution. And it's determined because those ratios are going to stay the same, okay? However, if we're given three angles, there are infinite solutions, because you can have similar triangles that are just like you have one here and then you have one that's the same angles, but it's just bigger, and so on. You can make that bigger, okay? So these are some situations. If you see one that gives you all the angles and it says to solve, unless you have a side, you can't solve it. If you see one of the first three solutions, angle, side, angle, side, or side, 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 then there's only one possible solution. Now, depending on what you know in one of those cases, it's going to determine whether or not you can use, sine or sine law or cosine law to solve. We haven't learned cosine law yet, but we will. However, when we are given two sides and an angle opposite one of those sides, the ASS, there are a few possible outcomes. So if you're given a triangle, you're given an angle and side, there are more than one multiple possibilities given the measures. So let's take a look. First, if we are given, we're given our angle A and side C the same, we can experiment what happens to a triangle if we start to manipulate side A. So remember, in this triangle, this is angle A, this is side A, and this is side C, okay? So taking that into consideration there, okay? That we're dealing with A, C, and A. Just making my diagram a little better. So, first case, side A is less than the height. So here we have our base, and then we have, here we have angle A. So this is A. This would be side C. This would be angle B up here. If side A is less than the height, this being the height of the triangle, then no triangle is formed. Because the only way to close off that triangle would be to draw a line like this, and that would change angle A, and that can't happen. So no triangle is formed, okay? If side A equals the height, so looking at that one, So we draw our base in. We have our A in here, right? This is side C, this is B. And if this is the height and this is what A is, A equals the height, then we get a right angle triangle. Okay, so there we go. Now we're seeing what happens, okay? There is another situation. There are two more situations. If we have our base, we have angle A, side C is there, B is right here. Let's sketch in our height. If the side A is greater than C, so it's longer than C, then what we get is we get an obtuse triangle because angle B is going to be obtuse. Angle B will be greater than 90 degrees, okay? Because it's got to be wide enough to allow that triangle to happen. Again, we get this from A, C, and A being given to us. Now, if we get case 4, and in case 4, A is less than the height, it's greater than the, I'm drawing this wrong, sorry. I want to get this right. If we get A is greater than the height, but it is less than C. So we have A here, we have our height in, C is there, but it's less than C, then we have two possible triangles. So I'll show you what happens. One would be like this. The other one would be like this. We'll imagine that this is A and it is the same length. It is, however, less than C and greater than the height. So what we get from this is we get two triangles formed. So you have to be able to compare A to the length of C as well as to the length of the height to tell whether or not we have the ambiguous case. So we're going to have from this, we'll have a triangle that looks like this, A, C, and A, and a triangle that looks like this, A, C, and A. Now in those two triangles, we clearly have different measures for B and B, and we also have different measures for angle C, okay? But A, C, and A are the same. So what we call this the ambiguous case because there are two possible triangles formed. Whenever you get angle side side and you're given those, you have to take a look at the measurements and determine whether or not it's the ambiguous case. Now it might not be. It might be the situation that we saw here with case 3. If side A is longer than side C, then there's only one possibility. Or it might be case 2, where A is equal to the height, and again, there's only one possibility there. Or you might have no solution, no triangle formed if it's less than the height. However, if it is greater than the height and less than c, you have the ambiguous case. So, so the conclusion is we can form two possible triangles, one with an angle C as an acute angle, so this would be angle C is acute, and one where angle C is obtuse. Okay, and if we want to see what that looks like, so C here is clearly less than 90 degrees, here C is clearly greater than 90 degrees. Okay, so angle C is, Mrs. Finley needs to get her signs correct. Angle C is less than 90 degrees. Angle C is greater than 90 degrees. Okay, so let's see how that works. So we're going to do an example here. So we have PQR. If R is 40, Q is 40.5 centimeters, and R is 35.2 centimeters. So from this, when we look at this, this would be Q, right? So it is 40.5 centimeters. R is 40 degrees. And then we have side R being 35.2. So we're going to have some situations here where we have to kind of test. So first we'll do the test. If this were a right angle triangle and we wanted to figure out what the height is, we would use our sine. So sine of 40 is equal to the opposite over hypotenuse. We know the hypotenuse and we are looking for the opposite, which unfortunately is called h, but that's okay. So sine of 40 is equal to the h over 40.5. So rearranging to solve, h is equal to 40.5 times sine 40 degrees. So h equals 26 centimeters. Now, R is 35.2 centimeters. It is R, so from this information, R is less than Q and greater than the height. So it fits the parameters of the ambiguous case. Okay, so we're going to have two triangles. So let's start solving and let's see. So I'm just going to get rid of this because I want to break my page up so that I can do both of these. So first of all, if we have our triangle R, with this being 40, this is 40.5, and this is 35.2. This would be P and Q. We're going to use our sine to figure out, our sine law to figure out the missing angles. So I'm going to look for sine Q. I'm actually going to change colors, sorry about that, just to make it clearer to see. So sine of Q over Q is equal to sine R over R. We have to use our pairs, right, with the sine law. So sine of Q is equal to Q sine R over R. Sine of Q equals, I substitute all that in. So 40.5 times sine of 40 degrees all over 35.2. Sine of Q equals, let me just figure that out. 40.5 times sine 40 divided by 35.2 is 0.7395 . So Q is equal to sine -1 of 0.7395 dot dot dot. Q equals 47.7 degrees, or we can say 48 degrees. Okay, now angle P will be 180 minus 40 minus 48, which is equal to 92 degrees. Let's just scroll this up a bit. Hopefully I'll have a little space here. I use a lot more room than I should have. So we have our angle Q, and we have our angle P. And to find the missing side, we would use the sine law to find that. So let's squeeze it in there. I know I can make it work. So to find P over sine of P is equal to R over sine of R. So P is equal to sine of 92 degrees times 35.2 all over sine of 40. So P is equal to, when I calculate that, I get 54.7 centimeters. So, and you'll notice I'm putting them in little boxes. That's so that I can find the answer. Sorry, I went over on the other page. I used up a lot of space for this one. Okay, so that's the one version. They're all, angle P is greater than 90 degrees, but angle Q is not, okay? So this is that one version. The other version, and I'm going to kind of expand it. So let's see what we have here. So the second version will look somewhat like this. P, Q, R. This is still 40.5. This is still 35.2, and this is still 40. Now you're saying to yourself, well, how do I know what angle Q is? Well, here's the trick. Those two angles, the Q that we determined in the first one, in the other case, angle Q is going to equal 180 minus 48 degrees. And you're going, where did you get that 48 degrees, miss? Well, we get it from here. Okay, so it comes from, I'm just going to write a different, it comes from that solution. So that 48 degrees, basically those, for the two cases, the angles of Q, they're complementary angles. So we already can figure out angle Q. So angle Q is equal to 132 degrees. Okay, and we'll put that in a little box. Now, to find our angle P in the new triangle, angle P is going to be 180 minus 40 minus 132. So angle P will equal 8 degrees. So this is a very small angle, okay? And then we have to find our last side. So we're going to do P over sine P using our new angle, sine, so it's equal to R over sine R. And I use R in this case because those are from the given information. You know, it's always best to go back to your original information. And substituting in here, P over sine 8 degrees equals 35.2 over sine 40. So P is equal to 35.2 times sine of 8 degrees over sine of 40 degrees. And P will be equal to 7.6 centimeters. Okay, so, you know, this doesn't happen all the time. It only happens when we're in that situation. My apologies there. So, you know, it's only going to be when you, and I mean, the acronym is telling when you have an angle side side that you have to test for it. And even sometimes when you test for it, you're going to get the situation where you just have one triangle. But it's important to be aware of the ambiguous case because it can happen. So, you know, and this kind of summarizes it in terms of those relationships. You can do the practice, get some practice with the ambiguous case, and just be aware of it, that there is more than one possibility.